going to do is we're going to solve radical equations. That's just going to be equations that have radical expressions in them. And we're going to use what's called the principle of powers property to solve them. Basically what that means is if you have an equation, like we have done with equations in the past, if I want to add something to both sides, or subtract something from both sides, or divide both sides by something, I can do that because I have two things that are equal to one another. Well, what we're going to do with the principle of powers, and when we have radicals, is we're going to raise both sides of an equation to a power. If I'm taking a square root, then I'm going to raise both sides of this equation to the second power, because I've learned that the square root of something squared is just that expression or that value that's underneath the radical. So by squaring the square root of something, I get that expression underneath, and the radical is gone. On the right-hand side, I'll have 49. And I have just a linear equation that I need to solve now. So we'll subtract 2 from both sides. And finally, we'll divide both sides by 5 and find out that our solution is 47 over 5. The one thing that you need to be careful of when you solve radical equations is that you need to check your answers. It's true of all equations, but it's particularly important here because frequently, and I mean very frequently, you're going to get answers that don't check in that equation. So if I were to put 47/5 into this expression as my check, I'm going to have the square root of 5 times 47 over 5, again substituting in for x, 47/5, plus the 2, and I'm wondering if that's going to equal 7. Well, the 5's here cancel out. They are common factors, one on top, one on the bottom, and what I have underneath the radical now is the square root of 47 plus 2. That's 49 underneath, and that is equal to 7, excuse me, and I'll put a check mark here and say that solution does work. I only want to use the principle of powers property when I have a radical alone on one side. And so the next problem that we're going to look at has this radical expression with a -3 with it. I've got to get the square root of x minus 1 alone, and to do that I'm just going to add 3 to both sides to begin with to make that happen. And after I've done that, then I'll use the principle of powers. Now I'll go ahead and square both sides. This is now clean to go ahead and do that. And the square root of x minus 1 squared is just that expression underneath the radical. I lose the radical. Over here I have 12 squared, which is 144. I'm going to add 1 to both sides, and my solution is 145. Let's check it. I don't know that we'll have time to check all of these, but fairly quickly, let's substitute in for x, a value of 145. So I have the square root of 145 minus 1, and then minus 3, and I'm wondering if all that is going to equal 9. Well, this right here is the square root of 144. I'm not going to write the whole expression out, which is 12, and I want to know if 12 minus 3 equals 9, and it does, and this solution checks. The principle of powers can be applied to any equation involving radicals, even those equations that involve cube roots, fourth roots, doesn't matter what the root is. The bottom line is that if I have an equation that involves, in this case, a fourth root, I'm just going to raise both sides of this equation to the fourth power. That will give me then what's under the radical, the radicand, or x plus 3. So I'm going to show my work that I'm raising both sides to the fourth power to keep the balance, and what I will have then from this expression is just what's under the radical, the x plus 3. 3 to the fourth power is equal to 81, and now all I have to do is subtract 3 from both sides, and I find out that x is equal to 78. Again, I'll check it fairly quickly. My original equation said the fourth root of x plus 3 equals 3, and I'm going to put an 81 in. I'm sorry. My solution was 78. I'm going to put a 78 in. And when I do that, it does look like I'm going to have underneath the radical a perfect fourth. The fourth root of 81 is 3, because 3 times 3 times 3 times 3 is equal to 81. And we have our solution. for the fourth root of x plus 3 equals 3, that solution is 78. This radical equation is a little bit different than the problems that we've done, the couple of problems we've done previously, and that is that on the side opposite the radical expression, there's two terms, a binomial, not a constant like we've had in the other problems. When I go to square both sides of this problem, I'm going to have a binomial squared over here on the left-hand side, and as a result, I'm going to have an x squared term in this equation. When that happens, I recognize that I don't have a linear equation to solve. I have one that I have to solve by factoring and using the zero product rule. So let's go ahead and look at this problem. I'm probably going to get two solutions, and I should make sure that I check them both. Let's square both sides first, because on the right-hand side, I have a square root symbol. And so I'm going to be asked to take this x minus 5 times x minus 5 on the left. The square root of x plus 7 squared is just x plus 7. When I FOIL this, I'll have x squared minus 5x minus another 5x is a minus 10x, and a minus 5 times a minus 5 is a positive 25. This is the point where I recognize that I have an x squared term, and that I have to use the zero product rule to solve this thing. So I have to factor it. I have to get everything on one side and 0 on the other. So as a result, next I'm going to subtract x from both sides, and I'm going to subtract 7 from both sides to clear the right-hand side so that there will be 0 left over there. I'm going to do that in one step. So I'll subtract x, and I'll subtract 7 from both sides of the equal sign. I lined those terms up underneath the like terms, and I'll have x squared minus 11x plus 18 equals 0. I've now got to factor this trinomial into the product of two binomials. I'll need an x in the front of each of those, and it looks like I'm going to need two numbers whose product is 18. Those two numbers are probably 9 and 2, because they have to add to be a negative 11. They'll have to have like signs, both negative signs, in order for that to work. The zero product rule now says that I should take each of those binomials, the x minus 9, and set it equal to 0, and the x minus 2, and set it equal to 0. And then finally, I should add 9 to both sides here, and find out that one of the solutions is x is 9, and I should add 2 to both sides here, and find out that one of the solutions is a positive 2. Now, I have to go back and check these solutions. I got to see that they both work, because very frequently you're going to find that solutions to radical equations do not check. So let's check the 9 first. I'm going to go into the original equation, which is x minus 5 equals the square root of x plus 7. I'm going to write that up here. X minus 5 equals the square root of x plus 7. When I substitute in a 9 here, I have 9 minus 5 equals the square root of 9 plus 7. And on the left, I'll have a 4. On the right, the square root of 16. And the square root of 16 is 4. And that does check. When I substitute in a 2 for x into the original equation, I have 2 minus 5 equals the square root of 2 plus 7. On the left-hand side, I have a negative 3. And on the right-hand side, I have the square root of 9. Well, the square root of 9 is equal to 3. That is not a true statement. You need to come back and tell me that this is not a good solution to this equation. This is the only solution to that radical equation, x equals 9, in spite of, after having done this algebra, having gotten this solution. Remember, we always have to check equations to be sure that they work. Make sure you do that throughout this section, because there's going to be a lot of problems where the solutions do not check. When a radical equation has a radical, or a radical expression on both sides of the equation, I have to use the principle of properties twice. So what I need to do is I need to be sure to write this equation so that one of the radicals is totally alone. So in this case, the 4x minus 3, the radicand, is all by itself, and I'm going to go ahead and square both sides. What happens, however, is while I'll get rid of the radical on the left, I will not get rid of the radical on the right. Once I've cleaned it up and simplified things, I'll have to use that principle again. Let's go ahead and square both sides. On the left-hand side, simple enough. The square root of 4x minus 3 squared is just 4x minus 3. However, on the right-hand side, I have a large binomial that I need to square, and in order to be real careful here, I'm going to write it out 2 times so that I can be sure to FOIL this properly. So let's go ahead and take the first terms. 2 times 2 is 4, and then here I'm going to have 2 times the square root of 2x minus 5. And you know this is just a binomial squared, so the inner terms are going to produce the same thing. 2 times the square root of 2x minus 5. And those are like terms, so I'm going to combine those, and I'm putting them one on top of the other right now. And finally, my last terms are the square root of 2x minus 5 times the square root of 2x minus 5, which is just 2x minus 5. Now I have to collect things on the right-hand side. Remember, I'm just working the right for right now. So I have 4 plus 4 times the square root of 2x minus 5 plus this 2x plus the minus 5 with an equal sign here and a 4x minus 3 over here. It's wise to not go ahead and think about squaring anything because you have this radical until you clean everything up. And as a matter of fact, I'm going to take this 4 and this minus 5 and collect those before I do anything. And then I'm eventually going to subtract 2x from both sides. My goal is to get this term all alone because then I want to square both sides again. So let's first go ahead and collect this 4 and this minus 5. It's a lot of writing to do it, but this is the way I would be doing this. So I would have a minus 1. I'm going to put the 2x next to it so you can see our work in the next step. And 4 times the square root of 2x minus 5, I'll put at the end, equals this 4x minus 3. And now I'm going to go ahead and do two things at once. I'm going to subtract 2x from both sides, and I'm going to add 1 to both sides. And I'll have 2x minus 2 equals, those are gone, so I'm going to bring this down over here, equals 4 times the square root of 2x minus 5. I've run out of space. I'm going to have to go onto another screen, another window, to finish this problem. So I'm going to take this step, put it at the top of the board when we come back in the next screen. Continuing on with this problem, I've copied where I was at that point. Now that I've gotten everything on one side and the expression with the radical on the other, I'm now going to go ahead again and square both sides. So I've had to do this for a second time in this problem. I'm going to write this out so I don't lose anything. You know, certainly that's not necessary for all of us. But I'm going to take 2x minus 2 and square it, and that's what this means. I have a lot of people who aren't thinking that when I ask you to take a binomial squared. On the right-hand side, 4 squared is 16, and the square root of 2x minus 5 squared is 2x minus 5. The radical is gone. We've squared both of the factors in that right-hand side. On the left-hand side, here I have a 4x squared, and then a minus 4x and another minus 4x is a minus 8x. We should be able to do this we should be able to do it from here in our head actually. A minus 2 times a minus 2 is a positive 4, but if you can't, this is what you would write. Then I'm going to distribute this. I have a 32x and distribute right here, and that looks like a minus 80. And now what I've recognized is that I have a problem that has an x squared term, so I've got to use the zero product rule again. So I've got to get rid of these two terms on the right-hand side. So to do that, I'm going to subtract 32x. And at the same time, normally we don't show both steps at once, but at the same time, I'm going to add 80 to both sides. So then I get 0 on the right. So I have 4x squared, and then minus 40x plus 84 equals 0. I'm ready to solve this quadratic equation by factoring. What I would need to remind you is that every problem that needs to be factored, you should look for the greatest common factor first. That was my broken record when we talked about factoring. There happens to be a 4 that factors out of this problem, and by factoring out that 4, that makes this a much simpler problem to solve. So I'll have 4 times x squared. I'll need a minus 10x, so that this times this will give me the minus 40x. And then it looks like I'm going to need a 21 as my last term. And now I have a simple trinomial to factor. That is, I want to put an x in the front of each of these binomials. I need two numbers whose product is 21. They have to add to be a minus 10, so they're both going to be minus signs. Looks like it's going to be a minus 7 and a minus 3 because that product is 21 and they add to be a minus 10. When I use the zero product rule, I only have to use the factors that involve x. There's no point in my setting 4 equal to 0. It does nothing for me and it's not a true statement. So I will set x minus 7 equal to 0, and I'll set x minus 3 equal to 0. This one will result in a solution of 7. This one will result in a solution of 3. Their checks are actually very, very simple, but remember that you're going back into the original equation, which is the square root of 4x minus 3 equals 2 plus the square root of 2x minus 5. It happens that both of these solutions work in the original equation. I'm going to leave the check up to you, but again, you really should be checking these equations. That's the last example that I've got for solving radical equations. Bottom line, if there's just one radical expression, get it alone, square both sides, or if it's square root, cube both sides if it's cube root. If I have more than one radical expression, I'll probably have to go through the process twice. I'll get a radical alone, square both sides, that radical will be gone, clean things up, get the other radical term alone, square both sides, see if I have a quadratic, see if I have an x squared term and have to use the zero product rule to solve, or maybe I just have a linear equation with one solution.